Hi, today we're going to find x, y, z using inverse matrix method. So first we're going to transform the linear equations into matrix form. So we're going to write all the coefficients in front of x, y, z into the matrix form, and then next to it is the values of 512 on the right side equal. So we're going to write that will be ax equals to b. First thing first is to find the inverse. What is the formula for inverse matrix? So inverse matrix is 1 over determinant times with adjoint. Okay, what is adjoint? Adjoint is cofactor transpose. Cofactor transpose, CT. Okay, secondly, we are going to multiply ax equals to b with the inverse because we're going to use inverse. So that's why I multiply both sides with inverse a. So that will be inverse a times a, you get identity. Identity times any matrix, you get the matrix x. Alright. So to find the inverse, first thing first is to find the cofactor. So what is the formula for cofactor? Negative 1 power of I plus j minor. Okay, so you're going to write the cofactor into the big bracket, very big bracket, because we're going to key in all the cofactors there. So first, cancel the first row, first column, cancel the first row, first column, then we get 3, 2, 3, 2. So key in into the first straight line. It's not a bracket, a straight line. So we're going to key in there. The second one is the first row, second column. So 1 plus 2 is 3. That's why you get negative. So key in all the elements there. Alright. So outside of it will be negative sign. Negative. Don't forget the negative because without the negative, that is actually minor. Okay. Third element for first row, third column. Okay, positive. And then for the second row we have to cancel the second row, first column. And then that will be negative because second row, 2. First column, 1, 2 plus is negative. So next, second row, second column. Yes, that is positive. Okay, proceed with the third one. Second row, third column is negative because 2 plus 1, negative. Power of negative 1 power of 3 negative. So that is actually alternately plus minus plus, positive negative positive. Okay, and then proceed with the third row. Don't forget the middle one is negative because third row, second column. So 3 plus 2 is 5. So we're going to key in all the elements. Yes, for the third one, third row, third column. Next is to cross multiply. So cross multiply 3 times 2, 6 minus 6, you get 0. And then negative 2 minus 2, negative 2 minus 2, outside of it is negative, 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 positive 6. Yes. So negative 6 minus 3 is negative 9. Negative outside, so negative, negative, positive 7. 2 minus 1. 2 minus 1 is 1. So negative, okay, 3 minus, okay, be careful for negative inside of it. Negative, negative, positive. So you get negative times with 5, so negative 5, so negative 7. 2 minus negative 2 is 2 plus 2, so you get negative outside of negative, you get 4, negative 4. 3 minus 4 is negative 1. Okay, close bracket. So then we're going to do the transpose. Exchange the row into column. Tukar row jadi column. So now, jadi ke bawah pula lah row dia. This is cofactor transpose. What is cofactor transpose? That is actually adjoint. Adjoint matrix A. So you're going to write properly. Proper way. So cofactor transpose is adjoint A. Yes. Okay. Now we're going to find the determinant using the first row. First row, okay, what is the formula? First row, A11, C11, A12, C12 plus A13, C13, all will be plus because we're going to use the cofactor. So the elements in the first row, 1, negative 2, 1, substitute there. Okay, we already find the cofactor, so you just key in the cofactor that we get previously. Masukkan je 0, 6, -9. Yes, so -12 minus 9, we get -21 for the determinant. You can check using a calculator. So for the inverse, we're going to key in 1 over determinant times with cofactor transpose. Join just now. Right? So key in all the values, all the elements in the adjoint, and then divide with -21. So it will be in single matrix. So kita bagi siap-siap dengan -21 tu. Dah simplify dah lah. Kecilkan nombor dia. Kecilkan nombor dah. Okay, kecilkan nombor. Kena calculator je, apa susah. So -1 over 21. Okay. Careful, kadang-kadang salah kira. Tulis pun boleh salah. Oops. It's supposed to be 5 over 21 there. Wrongly written. So for x, y, z, we're going to multiply the inverse with B. Matrix B is 5, 1, 2. So masukkan balik dulu inverse A. Inverse A. All the elements in inverse A. Okay, key in, substitute one by one. It's supposed to be 5 over 21 there. Alright, and times with 5, 1, 2. So if we multiply, it should be row multiplied by column, row by column. So blue times with the blue, green times with the green one. So 1 over 3. Okay, plus with the blue one times with 1, the green one times with 2. So -1 over 21 minus plus with 8 over 21. Okay, next, the yellow times with 5, blue times with 1, green times with 2. So we are actually, got typing error there. Yes, it's supposed to be 5 over 21. 5 over 21. Yeah, right. Now we get it correctly. 5 over 21. It's not 5 over 7. It's 5 over 21. Bawah tu 2 over 21. Okay. 5 over 21. Yes. Right. So finally, calculate plus all. Yes, negative. And then lastly, positive. Okay, do not leave your answer like this. You have to rewrite back x equals to, and then y equals to, lastly z equals to. Okay, so that's all for the final values. You can check with using your calculator. Thank you. Bye.